The question says factorize x raised to power 6 minus 1. So how do we factorize expression like this? We have solution. Okay, so here we have x raised to power 6 minus 1. So when we look at this, we can write this as x raised to power 3 raised to power 2. Okay, do not forget when we apply exponent law. Okay, we have something like this. So it means we multiply the exponent, the inner exponent, by the outside exponent. So by the time we do that, we have x raised to power 6, okay, which is something as this. So minus 1 square. Okay, for 1 square, we have it as 1. For x raised to power 3, everything squared, we have it as x raised to power 6, which is the same thing. Okay, so at this point, we can apply difference of 2 square, okay, and to do that, we have x raised to power 3 minus 1, and the other one will be addition, x raised to power 3 plus 1, okay. So when we look at this, okay, we can still factor it further, we can still factor this further. So how do we do this? We can write this as x raised to power 3 minus 1 raised to power 3, okay, which is this, and we can as well write this as x raised to power 3 plus 1 raised to power 3, okay. So when we look at this, if you apply difference of 2 square at this point, so at this point you apply difference of 2 cube. So when we apply difference of 2 cube, so what's the algorithm behind this? Let's say we have a raised to power 3 minus b raised to power 3, okay. So to apply difference of 2 cube at this point, we have this as a minus b, okay. So for the first one, we have it as a squared, okay. So we take this together, we have this as minus ab plus, so for the last one, we have this as b squared. So it's addition, okay. So when we apply this algorithm to resolve this, so for x cubed minus 1 cube, we have it as x, okay, x minus 1, okay. So we have this as x squared plus, so we multiply this together, we have this as x times 1, okay, plus, here we have this as 1 squared, okay, for this. Now, here when we simplify this further, we have this as x minus 1, okay. Here we have this as x squared plus x plus 1 for 1 squared. So this is the result of this. Now we have this as x raised to power 3 plus 1 raised to power 3. So the same way we apply difference of 2 cubes, we can apply the sum of 2 cubes. And at this point, the rule here is, let's say we have a raised to power 3 minus b raised to power 3, okay, sorry, plus b raised to power 3. To apply sum of 2 cubes, we have a plus b, okay. Here we have this as a squared minus, so when we multiply this, we have this as ab plus b squared, okay. So when we apply this algorithm to this, so for x cubed plus 1 cube, we have this as x cubed plus 1 cube, okay. So when we look at this, applying this, we have x plus 1, okay, into, for x, we have it as x squared minus, we multiply this, we have x times 1, okay, plus 1 squared. So when we resolve this, we have this as x plus 1, okay. And for this, we have this as x squared minus, when we multiply this with 1, we have this as x plus 1, which is 1 squared, we have it as 1. So this is the result as by applying the sum of 2 cubes to this. So we can combine the result of this together with the result of this. So for this, we have the result of this to be this, okay? The result of this to be this. So we can combine it together. So for this, we have this as x minus 1, which is our final answer, x minus 1. We can take this as x plus 1, Okay, we are combining. You can take this as s squared plus x plus 1. Okay, and the last one is s squared minus x plus 1. So we have successfully factorized this by applying difference of 2 squared, sum of 2 cube, difference of 2 cube. So factorize this. Thank you very much.